get started with the other things in Git. So last class we just saw from the architecture and the concepts of Git, right? So with the help of that, we'll just proceed further and try to create some repositories and do the changes and see how the workflow happens. Now, the first thing you need to know is download Git. So pretty much if it is a Windows machine or a Linux, it is going to be the same for Git because we are going to use the command prompt. So we are not going to use any UI, it is completely command prompt. So that way, if you go to the Git download site, you can choose any of the operating system's specific installer. Okay, so if it is a Linux, just make sure to run a command specific to what operating system that you're running. Or if it is Windows, then simply if you go ahead and click Windows, you will be getting a exe or a zip file, and inside the zip file you will be getting an exe. Just extract and install it. Okay, so pretty much even in my case, I have installed it on Windows and will be using the command prompt only completely. When you're using the command prompt, especially on Windows, if you have installed Git, you will be getting an option like this where you will get an option called Git Bash. Okay, now what exactly is this Git Bash? Now, if you go to a Linux operating system, by default, you will be getting a command prompt like this. The same thing, if it is Windows, the default command prompt is CMD that you are seeing like this. But when you have installed Git on Windows, additionally, it is going to give you one more command prompt called as Git Bash. Okay, so whatever that I'm seeing here, whatever that I'm using here is actually a Git Bash. Now, what is the advantage of using this? Now, I can use the normal Windows command prompt itself to call the Git command, but the advantage of using this special command prompt called bash command prompt is it will be giving me a bash environment on Windows. Once again, what is a bash environment? So if you go back to the Linux fundamentals, so bash is a shell, and on Windows you are able to now get a Linux-like environment. So that is the advantage where I will be using this command prompt throughout the class, where it will be giving me an environment as if I'm working on a Linux machine. So I'm going to use the Git command, and there is no change whether I use it on a Windows command prompt or on Linux. But the advantage of using this Git Bash command prompt is I can run some basic Linux commands so that it will be easy for us to do the day-to-day activity. Okay, for example, if I type a command called ls, it is going to work, and ls is a Linux command which will help us to give the list of directories. The same thing, it will not work here because it is a Windows command prompt. So that is how you can make use of this Git Bash, through which you can run all the normal Git commands, but additionally you can run the basic Linux command so that it will be easy for us, and we will be getting an environment similar to the Linux environment. Okay, so that is how I'll be using this. So this is only for Windows, because when you are using Linux, you will be getting directly a command prompt like this, not a Git Bash, but the environment which you are going to use will be directly a bash. So you don't need all those things on a Linux machine. So only if it is Windows and you have installed Git, make use of this. Okay. So now, once you have downloaded, the next thing what you need to do is just check whether Git has been installed by typing git-version. So right now I'm using 2.9 version, and once this much is done, the next thing what we have to do is we have to do certain configuration. Okay, so going forward, if you want to invoke Git, you have to call this executable called Git, and you have to pass some option, and any kind of command that you're calling from Git will be followed by it, and the naming convention will be very straightforward so that it is easy for us to understand. For example, if you want to do some configuration, the command will be git config. So the name will be quite simple for us to understand it straightforward. And any option that you are passing to the command has to be using double hyphen. So if you see a double hyphen, a value, then that means it is a argument or an option that you are passing to this command. So now when you are trying to set some values, you need to use a command called git config, which means you are trying to do some configuration. Now the git config actually has two type of configuration. One is global configuration, the other one is local configuration. What is the difference between these two? Now when you use this machine and use this Git, I can create more than one workspace, because in Git everything is workspace. That is what I said. Now there is no limitation for me on how many workspaces I want to create. I can create on the same machine. But if you want, for each of the workspace, you can actually specify some particular configuration. So if you do the configuration per workspace, then we call it as a local configuration. But as an organization or as a best practice, if you see, you will not be setting configuration for each workspace. So you should be setting the configuration globally, so that on this machine, using this Git, no matter how many workspaces I create, you should be having the same configuration applied. Then the configuration has to be done as a global configuration. Okay, so to do that, you will say git config hyphen global. Now, what are the configuration that you have to do? So basically, the configurations that we have to do is nothing but some kind of values that we have to store for the purpose of using Git. So that way, first you will be using a option to store the username as whom we are trying to work on the Git. Okay, so that way we will create a value called username, and corresponding to it, it will be storing a reference value of the name of you. That is the next one. You will be giving the email, and then there is one more option called push.default. So the push.default is something needed for creating the workflow that I'll talk about it later, but understand it is quite mandatory that these three things are important to set it. But along with that, there are a lot of other options which is available. Now it is quite not important for us, but the major things which is quite important is we need these three things. Okay, so we'll see why these things are needed as we get in. So the first thing what we have to do is try to set the configuration. So just type git config hyphen global, and you will say user.name and the specific user of the person who is going to work on this Git. So in your organization, when you are working, you will be giving your user ID or your complete name, and then the email. So once again, in the organization, whatever the email has been given to you, you will be using it. And then the last option, push.default. So you have set the values. Now, once you have set, if you want to see the list of values that has been set, you can just say git config list, and you can see there are many other default values like the width of the screen, the color, all those things, which is, as I said, it's not important. So majorly, these are the three values that we have set as in configuration. On the name of the user is going to be Adam, the user's email is going to be this, and a push.default has to be of the type called simple. So once you have done this much, we are ready to go ahead. So now, what is the first thing that we have to do in Git? So in Git, now we will start as a practice where, if you recall this diagram, I said everything is a workspace where a user will be creating his local workspace and he will be doing the changes. So if he wants to create this workspace, you have to create a copy from the central workspace or the central repository. So that is how first we will create a central repository or a workspace, and from that we will create new workspaces or local workspaces in which we will be doing the changes. Okay, and creating this central workspace or the central repository is a one-time activity, and after that it is all about how users are creating their local workspaces and doing the changes and then sharing it back to the central repository. Okay, so now if you look at the repository, basically there are two types of repositories in Git. So one is bare, the other one is non-bare. Why do I need two types of repositories and what exactly are them? So if you look, just now I was saying that there is a central workspace and a repository inside it, as well as there are user workspaces in which there will be again one single type of repository. So that is how a bare repository is nothing but a repository in which you will be able to only store and share the changes. Understand? A bare repository means a repository where you will be able to store and share the changes, and you cannot modify anything in the bare repository. Okay, so that is what we call it as a bare repository. So when do you use a bare repository? Typically all the central workspaces will have a repository, right? So that kind of repository is what we call it as a bare repository, or simply the central workspace is going to be a bare type repository where the users will be able to only store the changes and share the changes. Whereas the other type of repository is called as non-bare repository. And a non-bare repository is a one where you can even store and share, but additionally you will be able to see the files and modify the files. So that is the major difference between bare and non-bare. So in a bare repository you can only store and share, whereas in a non-bare repository you can store and share, plus additionally you will be able to modify the file. So that way all the user workspaces, that is the local workspaces which the user is going to create, will be of the type non-bare repository, because only in that he will be doing a modification and he can see the files and do the changes whatever he wants. Okay, so all the central workspaces will be of the type bare, and all the user workspaces or the local workspaces will be of the type non-bare. Getting it? Now, since in
Adam,
Git, yes,
you said that the non-bare repository, you can store and share less additionally the file.
can you repeat that?
How do you define like non-bare repository? Can you repeat it? You say is where you can store and share less additionary file. That's what you said?
No.
Oh,
So, see, the purpose of Git is to actually store some files and keep a track, right? That is the purpose. So,
yes.
a normal bare type repository, you can only store and share the file. You cannot modify anything directly in it. Okay, so all the central repositories will be of the type bare, because you are going to use it only for storing the changes and sharing the changes. You cannot modify anything directly. Suppose if you have a product and in the product you have a file called 1.java and you cannot modify it directly if the workspace is of the type bare repository. So if you want to do some modification, then we will be creating a workspace in which only if you have the repository of the type non-bare, you will be able to modify the file as well as store the file and share the file.
Okay.
Okay, so that way, all the workspaces which the users create will be of the type non-bear. Because as a user, you are interested to not just store the changes. How will you store it? Only if you do modification, right? So only on a non-bear repository, you will be able to see the file as well as store the file.
Okay.
Okay,
Yes.
so now how do you create? So as I said, we will go ahead with the workflow standard or the best practice where for the first time when you are trying to set up a project, you will be setting up a bare repository, and then going forward, you will be sharing that bare repository or the central repository with the users from which they will be creating a local workspace and they will be doing the changes. Okay. Now, going forward, when we are working, I might refer a workspace as a repository because in Git, if you see, a workspace is going to contain a repository inside it. So sometimes people will don't call it as workspace, they will refer directly as a repository. So that's why even I would be referring the central workspace as a central repository, because in the central workspace I'm not going to do any modification, right? So the only thing that you have inside is a repository, so I'll be directly calling it as a central repository. But on a local workspace, you need to see the file and modify as well as you want to store. That's why we generally call the local workspace as a complete workspace, and the central workspace is directly a repository. So how is that you are going to create a bare repository or a central repository? And once again, this is just a one-time activity when you are trying to create a new project. Now, what I'll do is, the first thing is, I'm just going to create a directory in my machine. So now I have actually created a folder called cwesba git just to store all the Git related repositories inside it so that it will be easy for me to look at it. Okay, so just create a directory under your machine anywhere, and now you have to go to it. Since I'm using the Git Bash command prompt, the format of the directory structure will be similar to Unix or Linux. It is not like Windows. Okay, so that's how I'll go to this folder. Okay, if you can see, it is the equivalent where the / that you can see is because this is a Git Bash command prompt. Okay, the Bash environment gives you everything in this, whereas the Windows command prompt will be understanding this way. Okay, so if you give this exactly in this command prompt, it will not be understanding. So make sure you are just replacing the backslashes with the / when you are using the Git Bash. So now in this, I do not have anything. The first thing that I'll do is I'll create a directory, and I'll create the directory with the name called as central.git. Now, if you look here, this is nothing but the name of my central workspace which I'm going to use for the project. So for our understanding, simply I just named it as central, and in that, if you see, I'm ending it with something called as .git. So whenever you are trying to create a central workspace or a central repository, it is always a best practice. You create the folder with the name ending with .git. So you can have whatever name you want, but end it with .git, because the naming convention represents that if a folder is ending with .git, then it is actually a central Git workspace or a repository. So that's how it will be easy for us to differentiate whether it is a central workspace or a normal user's local workspace. Okay. Now, once you go inside the folder that we have created, run the command git init and --bear. So generally when you say git init, you are initializing or creating a repository, and in that you are specifying that it has to be of the type bear. So it is created an empty repository in this folder. So now this is going to act as our central workspace or central repository. And as of now, we have just created it. So there is nothing inside it and it is going to be empty. Okay. So now going forward, as a user, we should be able to create a clone out of this or a copy out of it. And from that, we will be start working. So this command, that whatever you are doing is just for the first time, and going forward you will not be doing anything inside it. The only thing that we will be doing is the new workspace as a user you will create, and from that you will be doing the changes and you will be putting it back to the central repository. Okay, so now here, as I said, we just wanted to create a central workspace or a repository that we have created, and then going forward from this we will create different copies of the workspace and start doing changes as different users, and whenever they have completed their work and they want to share it back, then they will share it to the central workspace. So that way creating the central workspace is just for the first time. Now after creating the workspace, now we have to create these local workspaces for us, so that only in that we will be able to modify the files and see the files. Okay, so how is that we are going to create these local workspaces? So in order to create a local workspace which will be containing a non-bare repository, we will use a command called git clone. And for the git clone, we will say what is the central workspace against which you want to create a copy and the name of your local workspace. Okay, so now the central workspaces or the repositories, sometimes also called as remote workspace or remote repository. Okay, so now I have to use git clone and give the name of the central workspace from which I have to do a clone or a copy into the new folder, or the workspace name is what you will give it here. Okay, so that way now I'm just coming out of this directory and I'm just going to use the same directories to store all the workspaces. So here I'll just say git clone and then the name of my central repository. So it is not just the name, but you need to give the complete path of the central repository from where Git can do a clone. Clone means do a complete copy of the workspace, that is a central workspace, at that point of time. Okay, so you can either give like this, because currently we are in the same directory as where the central workspace is available. So either you can do that way, or simply give the complete path of the central workspace. So if you have the central repository in some other location and not on the same location, then you have to give the complete path from where the central repository can be accessed. And then what is the workspace name, so that you will be starting your work in that. So I'll try to say new 01. So now what is new 01? New 01 is nothing but our local workspace where we have just created a copy of the central workspace. So in this new workspace that we have created, which is going to act as a non-bare repository, we can do all the changes in this. Okay, and now looking at it, I can say that this is the central repository because you have a .git name in it. So let's go into new 01, and as you can see, it is nothing available because we cloned or created a copy from this central workspace which was quite empty. So that is how only for the first time when you create a workspace, you are seeing that everything is empty. But going forward, as we do some changes and store, it will be appearing, and that you will be storing it back to the central repository. Okay, but for now, what is that we did? We created a central repository, and since it is empty, from that we try to create a local workspace that is also empty. So going forward, let's start doing some changes by first storing it into this workspace or the repository. So new 01 is our local workspace which will be having the repository of the type non-bear. Because again, the basics of Git, every Git workspace will have one repository. But the difference is this workspace is going to have a bear type repository where I cannot modify anything in it directly. That is why we are going to create one more workspace of the type non-bear repository, and in these we will be doing the changes. Okay, so now we are inside our local workspace, and for the first time there is nothing in it. So let's go ahead and create some file and try to store it. Once again, here we are not interested on what is the content of the file, because we are interested only to understand the workflow. So don't worry about what is the content that you want to store, because Git as such doesn't care what is that you are trying to store inside the content. The only thing that it does is whatever content that you put, it will be tracking on what modifications you have done on it. So now when you go into the organization, pretty much a workspace will be used for a product. So a product will be based on some programming language. So based on what kind of programming language you are going to use, they will be storing all the files inside it. So let's say you are trying to create a Git workspace or a repository for a Java based project. So there will be a lot of Java files in your workspace. Now let me just create a dummy file first. Okay, so I'm using a command called touch. Once again, you see this is a Linux command, so pretty much it is easy for me to run using this Git Bash. So I have created a file called one.java. Now here what is this? So this is a workspace, and now a workspace has three areas as we were seeing yesterday, right? So what and all are they? The first thing is we have, what are the three areas of Git workspace?
Working directory, staging
Exactly, working
area,
directory.
and the repository, Git repository.
That's exactly right. So first you have the working directory, and then you have the staging area, and then you have the repository. So this is your working directory, and this is your staging area, and this is going to be your repository. Okay, so now once again, what is a working directory? The place where you will be actually able to see the file and modify the file. So in fact, now we are in the working directory where I have created the file. And as soon as you create the file, first you will put into the staging area, and from the staging area, you will be trying to store it into the repository. So this is the workflow that we will be going through. Okay, now in this, first what we have done is I have created a file called one.java. And do we have this one.java in the repository? Pretty much as of now, our repository is completely empty, correct? So any file that you have basically created in your working directory is not present in the repository, or in the other way, yesterday we saw any file which the repository doesn't have inside it, or it doesn't know about it, is going to call it as an untracked file, correct? So that way, if you run the command called git status, you can see it is going to clearly say that this file is an untracked file. So you are trying to do the first commit so that the file will be tracked. Okay. So right now you can see I've created a new file and it is treated as a untracked file. Now, once you have done some changes in the file, so the next thing what we have to do is, once again, yesterday in the basics we learned that if you want to do the commit, you have to go through two steps, where first you will put the file into the staging area, and from the staging area you will try to take a snapshot and you will be actually doing a commit. Okay, so now how is that you will put these changes or the files into the staging area? For that we will use a command called git add, and now you can specify a file which you want to add, or simply you can say dot, where if you say dot it can take more than one files, or whatever the changes that you have completely done in your workspace, it will take everything together and put into the staging area. Okay, so it's better to always use dot, so that if you have more than one file modified, it will take everything and put into the staging area. So now we have put the changes what you have done into the staging area, and if you run the git status, now the status of the file is no more untracked, because the staging area has a reference to the repository, and because of which it is saying that you have done some changes and you are ready to commit. So it clearly says in the green color that it has been put into the staging area and it is a new file that you want to add. Okay, now once you have put into the staging area, then you have to go ahead and do a commit. So to do the commit, you will say git commit, and you will give a practice as a message needed for this. So you will say git commit -m and a message. Now if you enter whatever files that you have modified and you have put into the staging area, that is here, everything will be taken, and correspondingly it will try to store it into the repository. Okay, so if I enter, now it would have taken the changes and put into the repository, and because of this, now you have a reference for this file called 1.java in the repository, and because of it, now whatever content you have here is the same thing what you have here. So the file will be treated as a tracked file, and in that it is an unmodified file. Okay, so now if you run the same git status, it will say that there is nothing modified, because everything whatever you have in a workspace is exactly the same what you have in the repository. Okay, so this is how you will be doing the changes and doing a commit. So let's do it quickly once again, where now in this I will try to add a line. Okay, so earlier the file was empty, but now I'm just trying to add a new line to the file called on.java. And once again, here I'm just trying to use a quick Linux command where I'm just printing this and redirecting it to this file. So rather than opening the file and writing, I'm just quickly putting it in this way. Okay, so the same way, what I'll do now is I'll create one more file called 2.java, and I'll try to add a line to it. So right now we have two files, one 1.java and the other one 2.java, and both of them you have a content called line 1, correct? Now at this point, if you do a git status, you can see that first it is saying that 1.java is modified, and you have not yet put the changes into the staging area. So it is saying that the changes are not yet staged. But the other file, if you see, it is calling it as untracked, because in the repository we do not have any details about the other file called 2.java. So now we have to put both of them into the staging area. So once you have done all the changes, the next step what you have to do is add them to the staging area. So to do that, I'll just do a clear. So to do that, if you just say git add and dot, what it will do, it will try to take all the files from your current directory or the workspace on which you have modified the file. It will be taking everything together. And now if you type git status, you can see that it has been taken into the staging area, and these files are no more untracked files. So that is how it clearly says that this is a modified file and this is a new file, and both of them are ready for the commit. Okay, so how will you commit? Simply say git commit -m, and you will be saying the commit message, where right now what is the commit that we did? It is a set of changes. Okay, so like this, when you are actually working in Git in the production, we will be doing modification on more than one file, and you will be storing a set of changes together as every commit. So every commit is not specific to one file, but it will be specific to a set of changes. Okay, so we created changes and stored that into the repository. So like this, every time if you want to do some changes, you just go ahead and modify the existing file, or you can create a new file and modify. But for the first time, only then you will be creating a new file. But going forward, you will be just modifying on an existing file and trying to create your project by different files. Now, if you go back once again on the previous class, every time you actually do a commit, what is that you are going to do? I said you are going to create something called as a commit ID, which will be a 40 long characters and a unique one, correct? So that way, now in this workspace or repository, how many commits did we do? We did 2 commits, right? First one is trying to store the empty 1.java file, and second time we modified 1.java as well as created a new file called 2.java, and we did a commit second time. So we did 2 commits, and corresponding to that, now Git will be having 2 commit IDs, and that is what exactly it will be storing in the repository and keeping a track of what has been modified using those 2 commit IDs. So if you want to see that, simply say git log, and it will be displaying you all the commit IDs that is available in your current workspace. Now, that is because, as I said, every workspace will have a copy of the repository for it itself. And if you see here, entirely this is called as workspace, and the repository is inside it. So anything that you store in the repository is known only to this workspace and not outside. Once again, this is the basics that we saw yesterday. So that way, if you look now, these are the 2 commit IDs, where the first time then I did a commit, it has created a 40 characters. This is the unique commit ID for the first commit that we did, and corresponding to it, now you see, using the configurations that we have done first, it is going to take the value and store it. So that is how it is going to store on who is the user who is operating or doing the Git commands, and then what is the email, and what was the date and time on which it was done, and what was the commit message. Because without this commit message, it will not be easy for us to just look at this random number and determine what you exactly did. So that is why it is a best practice to always give a commit message when you are running the commit, and it is quite mandatory. Okay, so like this, every time you do a commit, you will be getting a commit ID, and corresponding to it, all the factors through which you have created the commit ID will be there. Okay. Now, as I said, where is the changes that we have done so far? We have done all the changes in our local workspace, correct? So we have done all these changes on this local workspace. So will these commit IDs that we have created will be available in the central workspace? Will it be available?
No,
No,
Why?
because we
because it
didn't
is not
share
yet
it.
pushed.
Sorry, can you repeat it?
Because maybe like we should share it with the central repository.
Yeah, and before that, anything that you do, is stored only in that workspace, because this workspace has a copy of its own repository. That is how whatever changes that we have done is actually stored in the repository of this workspace. So when we are working on this, inside this we have a repository. So all these things are stored inside this workspace and in that repository. That is why I am able to get this command output. So if you go back to your central repository, okay, let's say I'll go to the central repository, and in this, if I type git log, it is saying that there is no commit. That is because this is still empty, because it has its own repository. So that is how whatever that we have done is local to this workspace. Remember, anything that you do in that workspace or the repository is known only to that repository. So now, what is that we have to do, so that if you want to share these changes from your workspace to the central repository, so that you are going to store it here permanently, and if anyone else wants to share, they can share it from this. So this concept or the process of getting the changes from your local workspace and putting it to the central repository is what we call it as a push. Okay, push means you are trying to take the commit IDs which you have only in your workspace, and that you are trying to store it into the central repository is what we call it as push. Okay, so whenever you do a push means you are trying to take all the changes that is available only on your local workspace, and that you are going to put it into your central repository. So to do that, once again, I will use the command called git push. Now, when I say git push, how will the workspace or the local repository know where exactly to push? That is when the other configuration that we had set some time back, that is push.default, is simple. So what it is going to do is, it is going to help us where this workspace will now remember that what is the origin of this. So what do you mean by origin? Origin is nothing but the workspace or the repository from where you have created the clone. So from where did we create the clone of this workspace? We created it using this central repository, right? So whenever you create a new workspace, it is going to keep a track of the origin, and because of the option called git dot, that is push.default is simple, automatically when you say git push, it is going to connect to the origin, that is the central repository of this workspace, and push the changes whatever that you had from your local workspace to the central workspace. So now if you go here and type a git log, you'll be able to see the changes available in the central workspace. You can see that it is available. So like this, now a user will be creating new workspace, and in this he will be doing all the changes first, and whenever he feels that it has to be stored back to the central repository because others have to use and do some other work, then at that point he will be doing a push. Okay, now let's try to create one more workspace. Now let's say that we are a new user. Okay, so as a new user, I want to work, so I need a workspace, correct? So what I'll do is, even whenever I want a workspace, I will just say git clone, give the name of the central repository or where it is available, and your new workspace name. Okay, so now if you look, what is the clone doing? At that point of time, whatever you have inside your central repository, you are going to completely clone and put into this new workspace. So clone means what? You are duplicating it exactly. So exactly when? Exactly at that point of time, whatever you have in it, you are going to get it inside the new workspace. So Now if you go to this, what is the content that we have in the central repository? Basically, we saw in the central repository there are two commit IDs, and corresponding to that we had two files called 1.java and 2.java, right? So now everything will be available in your new workspace, unlike the first time that we did or created from scratch. But here now this is how there will already be some content in the workspace. So the user who comes, he will be just doing a git clone, and in that he will be getting the changes. On top of it, he will be able to do some changes and store the changes first in his local workspace, and from here he will try to push it to the central repository. Okay, so now anything that I do in this workspace will be known only to this workspace, because this workspace also has a copy of repository, right? So whatever that I've created now, assume I've created this also has a copy of the repository. So anything that you do inside it will be stored only in it. Let's try that quickly. So we have two commit IDs, right? So now I'll try to create a new file called 3.java. Okay, and I just have a content called line1. And if you do a git status, this will be saying it as a untracked file because it is a new file. Okay, and how do you add to the staging area? Say git add dot, and now it has been added to the staging area, and I'll do a git commit. So I'll say adding new file 3.java from new 02 workspace. So we have added it, and corresponding to it, if you do a git log, you will get one more commit ID, and that commit ID is corresponding to this new file that I've added, and that will be available only in this workspace. That is, only in this it will be available. So now if you want to share that to the central repository, you will do a git push. So you can see we got this new commit ID now, correct? And this will not be available on the central repository or the remote repository. So now how is that you will share? So from your workspace, if you want to share the changes to the central repository, you will do a git push. Okay, so it understands the origin of this. So even the origin of this workspace is this central repository. So automatically it will try to push all the changes which is not available. So in the central repository, we already had these two. The only thing that was not available is this commit ID. So all the commit IDs, whichever is not available on the central workspace and that is available in your workspace, it will try to push. So if you do a git log now, in addition these two, you will also be getting this new commit ID that is 937E. Okay. So like this, what is that we did? Now we had this three workspaces. So first we created the changes from the workspace 01, and then we stored it to the central repository, correct? And then after doing the changes, we created a new workspace, and from this, once again, we try to push the changes to the central repository. So like this, now, first we created the central repository, and from the central repository, we created a new workspace, and then once the changes has been done, we try to do a push from here. Okay, then we created a new workspace based on this, that is the clone, and after that, whatever changes that you have done, from here we put it into the central repository. So like this, every time you create a new workspace, you first store everything in your local workspace, and from there you try to push it to the central repository. But if you look very carefully, now first when I created this, I did 2 commit IDs in this, right? And then I stored it. And from this I created, and then I did one more commit. So I had 3 commit IDs here. Corresponding to that, the third commit that you did is available in the central repository. Now, if I want, I can create a new workspace as a user and I'll be getting it. But assume about this workspace or this user who had the workspace. He has only the older commit IDs. Now, how is that if he wants, he should be able to get the latest changes from the central repository to his workspace? So the scenario is, if you already have a workspace and you want to take the latest changes what others have done. In this case, now we created a 3.java from this workspace and we stored into the central repository, right? So how is that on this workspace you can get that 3.java? Okay, so that is when we'll have to do the opposite of push. What did you do in push? From here you put the changes to the central repository. But now what I want is from the central repository I need to update my local workspace. So that way the opposite of push is pull. Okay, so now anytime if you do a pull, we will be updating our workspace with whatever commit IDs that is not available in the workspace and that is available in the central repository. Okay, so if I go back to this, you can see that I do not have the new commit ID because that is available only in the central repository. So now if I want to update my workspace with the latest changes that others has pushed to the central repository, then I would have to do a pull from that workspace. Okay, I have only 2 commit IDs. So now if I do a git pull, it will connect to the central repository, that is the origin, and from the origin it is saying that currently you have this as the commit ID and you are updating the latest commit ID to this. So next time it is not saying anything because your workspace is up to date. And if you do a git log, now you can see that you have obtained all the latest commit IDs, and corresponding to that you also got the new file which you have modified for this. Okay, so that is how first you create a workspace and do the changes, and once the changes is done you will be trying to put it to the central repository by doing a push, and whenever someone else does the push to the central repository, your workspace will be out of date or outdated. That is when if you want to update your workspace with the latest changes in the central repository, you will do a git pull, where from the central repository you will be updating your workspace with the latest changes. Getting it?
Yeah. Yes, sir.
Others?
Yes, it's okay.
Okay, so I'll stop it today, but quickly. To create a workspace, first time you will use git init, that is specifically to create a repository of the type bear. And then to create a clone, or whenever you want to create a user workspace or a local workspace, you will say git clone and give the central repository name and your local repository name that you want to create. And then if you want to do some changes and add it to the staging area, you will say git add. And if you want to look at the status, you will say git status. And to store the changes from the staging area to the repository, you will say git commit, and you will give the message using -m. And once you have done the changes, if you want to push it to the central workspace, you will say git push. And the same thing, if you want to update your workspace with the latest changes based on the central workspace, you will say git pull. Okay, so this is the regular workflow which a user will be working, and you will be doing the changes. Okay, so practice this today, and in the next session, we'll try to understand certain other concepts that we have in the repository. Other than the workflow, what are the things that we need to know for administrating or maintaining the workspace? We'll try to understand it. Okay?
Okay.
Okay, Adam, no problem.
Okay. So, do you want to have a class tomorrow?
I don't have any problem. If everyone are okay with that, then.
Well, Sunday would be good. I know I have some little stuff to do, but
I didn't get, sorry, there was some. You want to have or you don't want
yeah.
to have?
No, not tomorrow.